Hello students, I hope you all are doing good and preparing well for DCET exam. So this is the third video of differentiation chapter. So I would suggest you to watch my previous two videos. After that you can watch this video. Okay, so let's start today's session. So this is the syllabus for differentiation. Okay, according to the DCET. Okay, so we have covered everything. So today we are going to cover this part, application of differentiation mostly. Okay, so let's quickly look through the concepts that we are going to cover today. So we are going to cover a different type of differentiation, that is logarithmic differentiation, differentiation of a parametric form, and application of derivatives. Okay, let me just increase the thickness. Okay, yeah. Okay, so let's start. So logarithmic differentiation. So before we start logarithmic differentiation, you need to know some basic laws of logarithm, that are log mn. Log mn is nothing but log m plus log n. Similarly, log m by n is log m minus log n. Log m power p is p log m. So this one is very important. This one we will be using more frequently. Okay, yeah. So let's start. So this is, I have picked a question from previous year, which is y equal to tan power x. Y equal to tan x whole power x. So when you have these kind of functions where it is f of x whole power g of x, right? When you have these kind of functions, you need to use the logarithmic rule. So what we'll do is we'll apply log on both the sides. What do we get? Log y log tan x whole power x. So using the laws of logarithm, this is nothing but x log of tan x, right? Now I'll do my differentiation. I'll apply differentiation on both the sides. I'll get uh, differentiating log y, I'll get 1 by y. Differentiation of y with respect to x is dy by dx. I've applied the chain rule. Now here I apply the product rule. First function x, differentiation of log tan x, let me write it completely. Okay, plus second function, differentiation of first function, log of tan x, differentiation of x. Okay, coming to our second step. Okay, so here I'll apply the chain rule. Differentiation of log tan x, differentiation of log x is 1 by x, that is 1 by tan x. Differentiation of tan x is 6 square x. What I have done is I have applied the chain rule. Similarly here log tan x, I'll just write it directly. Differentiation of dx by dx is 1, right? Just simplify this. X1 by tan x is nothing but cot x, sec square x plus log of tan x, right? So my dy by dx is nothing but this multiplied by y, right? This y will come here, right? So this is my answer. Okay, so the correct answer is option B. Okay, tan x whole power x log tan x plus x cot x sec square x. Okay, it is easy. So you have to first see whether it is of this form, f of x g of x. If it is of this form, you will apply log on both the sides. Let's look at one more question. So again similar question we have. So again here it is y equal to x power y. Again we'll apply differentiation of log on both sides. Log y. Second, I just reduce the thickness, man. Yeah. So this will be y log x. Now differentiating on both sides, 1 by y dy by dx. I'll apply the product rule now. Y d by dx of log x plus log x dy by dx. So y dy differentiation of log x is 1 by x log x. Differentiation of dy by dx is same as it is. Now I have to take common, right? I have to take dy by dx is common. When I take that common, I'll get 1 by y minus log x is equal to y by x. So on simplification, this will be y square 1 minus y log x. So correct answer is option C. Okay. Yeah. So if you come across these kind of functions, you have to apply log on both the sides and I applied a differentiation of both the sides and solve it. Okay. Moving on. So this is an interesting question. Okay, I picked this question. Okay. So yeah, let's solve. So we have been given y is equal to 2 cos 3x plus 3 sine 3x. Let me change the pen. I'll take red pen. Okay. So I'll apply differentiation of both the sides. dy by dx. Differentiation of 2 cos 3x is nothing but 2. Differentiation of cos 3x is minus of sine 3x plus 3. Differentiation of sine 3x is cos 3x, and this 3x is 3. Here I missed the 3x. I'm so sorry. This is 3. So this is nothing but minus 6 sine 3x plus 9 cos 3x. Again I'll differentiate it. D square y by dx square minus 6. Differentiation of sine 3x is cos 3x. Differentiation of 3x is 3. Here again differentiation of cos 3x is sine 3x minus sine 3x. Differentiation of 3x is 3. So I'll get minus 18 cos 3x plus minus 27 sine 3x. I can take 9 as common. Minus 9, 2 cos 3x plus 3 sine 3x. So this is nothing but minus 9. This is nothing but my y, right? This is y, right? So on further simplifying this, I'll get d square y by dx square plus 9y is equal to 0. So the correct answer is option D. This was a slightly trickier question, so that is the reason why I covered this question. Moving on. So now we are going to do different kind of questions. These are called differentiation of functions in parametric forms. So this is a parametric form. So x in terms of theta is given and y in terms of theta is given. So how to solve these kind of questions? Okay, let's see. A cos square theta. So this one we'll differentiate this with respect to theta. Dx by d theta. So constant will keep aside. Differentiation of cos square theta. So here we'll be applying the chain rule. First we'll be differentiating the product power, that is 2 cos theta. Then cos, what is differentiation of cos? It is minus sine theta. Simple, right? Done. Now coming to our y, that is b sine cube theta dy by d theta. Constant will keep as it is. Differentiation of sine cube theta is 3 sine square theta. Okay. Now differentiation of sine is cos theta. Simple. Now I'll take these two. Let me call this 1, this 2. Now I'll do 1 divided by 2. So I'll get dy by d theta divided by dx by d theta, which is nothing but dy by d theta, dy by dx. Now if I'll just substitute in this b sine square theta cos theta 3b 2a cos theta sine theta minus. So cos will get cancelled, sine will get cancelled, and I'll get minus 3b sine theta by 2a, right? So the correct answer is option A. Moving on. So this is a differentiation of equations in parametric form. So again here x is given in terms of t and y is given in terms of t. Same thing. First we'll differentiate x dx by dt, which is differentiation of tan inverse of t is 1 by 1 plus t square, correct? Y 3t plus t cube. Similarly here again we'll differentiate it with respect to t. So it will be dy by dt. Differentiation of 3t is 3. Differentiation of t cube is 3t square. We'll take 3 common, 1 plus t square. So now the same thing, dy by dt dx is 3 1 plus t square divided by 1 by 1 plus t square. What do we get on simplification? 1 plus t square whole square. Correct answer is option B. Simple. Okay. Yeah. Moving on. This is actually, we are going to the different topic, that is application of derivatives. Application. So, how to solve this kind of question? Our objective is to solve the questions in the exam. So, I'll be quickly giving you how to solve that. So, let's first read the question. The rate of change of volume of a sphere with respect to its radius when its radius is 3 centimeter. Okay, so first what you will do is, they are talking about volume of sphere. So simply write the volume of sphere. Volume of sphere, what is volume of sphere? It is 4 by 3 pi r cube, right? Finished. This one thing, just extract this thing from the question. The rate of change of volume with respect to radius, that means dv by dr, right? Volume with respect to radius. Okay, so differentiate this with respect to radius. 4 by 3 pi, differentiation of r cube is 3r square, dr by dr. So this is nothing but 4 by 3 pi 3r square. So r they have given us as 3 centimeter. 4 by 3 pi 3 3 square 3 3. So this is nothing but 3 3 is a 9, 9 4 is a 36, 36 pi. The correct answer is option 4. So first look for what they are talking about. They are talking about volume of sphere. Then see on with respect to what we need to differentiate. Here we need to differentiate it with respect to radius. So we differentiate it with respect to radius and we find our answer. So this is how you approach this kind of question. So we'll see one more question. Okay, so here the rate of change of surface area of a sphere is 12 centimeters square per second. The rate at which the radius is changing when the radius of sphere is 2 centimeter. So they are talking about the surface area. So first thing what we'll do is, surface area of a sphere S is equal to 4 pi r square. Everyone knows this formula, right? They have already given us the rate of change of surface area with respect to time, because it is 12 centimeter cube per second. That means with respect to time, ds by dt is already given to you, that is 12 centimeter per second, because they have given you it as 12 centimeter per second. It is with respect to time. Okay, and they are asking us what is the radius at which, when the rate at which the radius is changing when the radius of the sphere is 2 centimeter. So they are asking us dr by dt when the radius is 2 centimeter. Okay, now first we'll differentiate this with respect to time. ds by dt, 4 pi, the constant will come out. Differentiation of r square is 2r dr by dt. So now the radius is given to us, it is 2. dr by dt is something that we need to find out. ds by dt is 12. Okay, 4 4s are 16, so 4 1s are 4 3s are, okay, 3 by 4 pi. So dr by dt is 3 by 4 pi, right? Okay, so the tip to solving these type of questions is, we need to find out what they are talking about. They are talking about sphere, so write the formula for sphere. Then try to find out on what, with respect to what they are differentiating. Here they are differentiating with respect to time. Okay, time. So that is only the thing you need to know, what is the formula, then in with what respect they are differentiating. Moving on. So this is the second type of question. So here it is a kind of multi-concept question. Here you will be also using what you have learned in your straight lines session. Okay, they are asking us the equation of normal to the curve y equal to x square at 2 comma 2. So yeah, this is a very interesting question. So x square graph is something like this, right? Y equal to x square. Oh, I'm so sorry, this touches the origin, right? Yeah, so this is something like y equal to x square, 2 comma 2 is somewhere here. So the normal is this one. This is the tangent. This is our tangent at 2 comma 2. Normal is perpendicular to this line. This is my normal. This is my 2 comma 2. So they are asking us equation of this normal. So to find equation of a line, what do we need? We need the slope and a point. We have a point, but we don't know the slope. How do we find the slope? Okay, so if you have referred my first video in introduction to differentiation, I have discussed what do we exactly mean by differentiation, right? Differentiation, the geometric meaning is it gives us the slope. It gives us the slope. The differentiation gives us the slope at that particular point. So I'll just explain you. So let's differentiate this. Dy by dx is equal to 2x. So at 2, at x equal to 2. So what is the slope at x equal to 2? So the differentiation at x equal to 2. 2 x, I'll substitute 2, the slope. So the slope of this tangent is 4. But I need slope of the slope here is 4. I need slope of this normal. These two lines are perpendicular. That means if I take this as m1 and this as m2, what will be m1, m2? Tell me. It will be minus 1, right? Because slope of perpendicular lines is minus 1. So 1 is 4, 1 is m2, 1 is minus 1. So m2 will be minus 1 by 4. So now I have the slope of the normal, that is minus 1 by 4, and a point. Point is 2 comma 2, right? So using this, I can find the equation of the line, right? Point slope. So the formula is y minus 2 x minus 2 is equal to slope. So this gives me 4y minus 8 minus x plus 2 x plus 4y minus 10 is equal to 0. X plus 4y minus 10 is equal to 0. So the correct answer is option 3. So this is a slightly trickier thing. So the thing we need to know is the differentiation gives us the slope of the tangent. Okay, this is the slope of the tangent. We need to find the slope of the normal, that is minus 1 by 4. Then we'll simply apply the point slope formula to find the equation of the normal. Moving on, this is a similar question. So they are asking us the equation of normal to the curve. So we have given the y 4x cube plus 3x square plus 4. So first I'll do the differentiation dy by dx. This is 3x square, 12x square, 6x plus 4. So the slope at x equal to minus 1 is, I'll just substitute minus 1. 12 minus 6 plus 4, 6, 10. The correct answer is 10. The slope is 10. But the slope of the normal is, we know it is minus 1. So m2 is minus 1 by 10. So if this is m1, m2 is minus 1 by 10. We know the slope, we know the point. Now I'll just apply the point slope formula. Y minus y1 x minus x1 is equal to minus 1 by 10. So 10 by minus 30 minus x minus 1 x plus 10y minus 30 29 equal to 0. Sorry, we have done something mistake here. Let me check. Minus 1 3 minus x minus 1 y slope may we have done some mistake here. Let me check. 12 16 10, yeah, slope is minus 1 by 10. 5 minus 3x plus 1 minus x minus 1 10y minus 30. Yeah, everything looks fine. Equation of normal to the curve. Oh, let me check once again. What did I miss? Oh, 4 is not there, no? Differentiation of 4 is 0, right? This is the mistake. Okay. So the slope what we have got is wrong. The slope is 12 minus 6, which is 6. So it is minus 1 by 6. The slope of the normal is minus 1 by 6. So y minus, so the point is minus 1 comma 3. y minus 3 by x plus 1 is equal to minus 1 by 6. Okay, so this is 6y minus 18 minus x minus 1 x plus 6y minus 17 is equal to 0. So x plus 6y minus 17 equals 0. The correct answer is option B. So this is how you solve the question. So the slope was minus 1 by 6. The point is minus 1 comma 3. So that is how we found the equation of the line. I hope this session was helpful to you. So you can like the video and share this with your friends. And if you have any doubts, you can ask me in the Telegram group. You can join my Telegram group. There you will get all the latest updates and you can ask for your doubts there as well. Okay. Yeah, that's all for the session. Thank you.